All right, today we're going to be working on number 9, rational notes, simplifying rational expressions without factoring. So in math, there's one number that we cannot divide by, and that number is 0. And we learned that on the last 2 lessons. So you cannot divide by a 0. You get that divide by 0 error on your calculator if you were to do that. And then to find these undefined is what you call those. Values, we look at the bottom of the fraction. Okay, so let's look at this first one. So if we can't have 0 in the bottom, then either this part of the parentheses or this part of the parentheses cannot be 0, because if you multiply anything when those two parentheses are sitting next to each other, if you multiply them together, and one of them is a 0, they'll both become a 0, and then it just turns into 0 on the bottom, and you can't have that. Okay, so the first thing we're going to do is this x plus 4, and we're going to set it not equal to 0. Okay, we're going to do it the same thing. If that were an equal sign, we're going to do it the same thing. So if it's x plus 4 and we want to get rid of that minus or that plus 4, we're going to do the opposite. So I'm going to subtract 4 from both sides. And then I get x cannot equal, and then 0 minus 4 is negative 4. Okay, I'm going to do the same thing with the other one. So I have x plus 2, and I'm going to say cannot equal 0. And then to get rid of that plus 2, I'm going to subtract 2 and subtract 2. Then I'm left with x on my left side cannot equal, and 0 minus 2 is negative 2. So then I can say x cannot equal negative 4, and x cannot equal negative 2. So our directions are just to state the undefined value for each rational expression. So this is stating our undefined value. So we're done there. Okay, so let's look at number 2. We're going to do the same thing with number 2. So I don't want this to be 0, and I don't want this to be 0. So I'm going to set them equal to to 0. So I'm going to say x minus 3 cannot equal 0. To get rid of minus 3, plus 3, plus 3. You always do the opposite. So x cannot equal 0 plus 3 is 3. I'm going to do the same thing with my x minus 2. X minus 2 cannot equal 0. To get rid of minus 2, I'm going to say plus 2, and I get x cannot equal 0 plus 2 is 2. So I have my 2, x cannot equal 3, and x cannot equal 2. Okay, let's look at number 3. We're going to do the same thing, but we're going to do this one a little bit differently. Actually, let's go back to number 2 while we do this. Okay, so notice in number 2, when we looked at that first one, this red one right here, where it says x minus 3, okay? Notice your x is all by itself except for that minus 3. So when that was a minus 3, this was our opposite where it was a positive 3. Notice when this was a minus 2, to get x all by itself, this is going to be a positive 2. So if your x is all by itself, you're just thinking, what is the opposite? So we can do some of these kind of fast without having to put a lot of work into them. Okay, so let's look at number 3. The first one I'm going to look at is this x minus 8. Right now it's a minus 8. So now my x is going to be the opposite. X cannot equal a positive 8. Let's look at my next one. This one's x minus 2. So it's going to be the opposite. So x cannot equal a positive 2. So that one is right there. So that's kind of easy. Goes a little bit faster if you don't have to set it all up. Okay, let's do the same thing with number 4. I have this is x plus 6. So if I want the opposite, x cannot equal, the opposite of a positive 6 is a negative 6. This one says x minus 1. The opposite of a minus 1, x cannot equal a positive 1. Okay, so that's the fast way how you would find the undefined values when your x is by itself. If your x is not by itself, meaning it has a number like 2x plus 6, it's going to change a little bit, but not by a lot. And I think you're going to find this method that we're doing it quick and easy for you. Okay? When we're simplifying rational expressions, the first thing you want to do, and I don't know why these directions are on there, they shouldn't be, is factor the top if necessary, and then factor the bottom if necessary. Okay? On the back side of this, you won't have to do any factoring. So I'm not really sure how those directions or why those directions are on here. So you can kind of ignore step 1 and step 2. We're going to go right to step 3 today. Cancel out any factors that are the same. Okay, so if you have the same thing on the top and the same thing on the bottom, those cancel out. It's kind of like saying 5 divided by 5. Well, 5 divided by 5 is 1, and whatever you'd multiply by that 1 is going to stay the same, so it wouldn't change at all. That's why we can cancel those ones out. And then the last part is state the undefined value, which is what we just did on top. Okay, so let's flip over and look at some of these on the back. Okay. So right away, I would want to state undefined values first before I cancel things out. So I'm going to say, when I look at this first one, I'm just going to take the opposite, and then I'm going to take the opposite of that one. So I'm going to say x cannot equal, and x minus 4, it's a minus 4, so it's going to be the opposite. It's going to be a positive 4. And then x cannot equal, it's a positive 3, so now it's going to be opposite. It's going to be a negative 3. Okay? But if we go back, so I like to do that before I cancel out so I can see them really well. Well, if you have, when you're simplifying rational expressions, if you have the same thing on the top and the same thing on the bottom, for example, I have this x minus 4 right here. I also have an x minus 4 right there. When they're top and bottom, it's kind of like that 5 divided by 5 that I was saying. They just cancel each other out. So this is gone and this is gone. So now I'm left with that x plus 3 on the bottom, and you can keep that in parentheses if you want. You don't necessarily have to. If it's the only thing down there, you wouldn't need parentheses under it. And then if there's nothing left on the top to hold that place, you're going to put that 1 to hold the place. Okay, so let's try to do the same thing with number 6. Okay, so this one right here is going to be easy. Okay, so let's just do that one quick before we work on the next one. So I'm going to say x cannot equal, right now it's a negative 3, so it's going to be a positive 3. Okay, this blue one, we're going to do one way on this time how to solve that, and then I'm going to show you a faster way to do it after this. Okay, but if you want to revert back to this way, if this one makes more sense to you, then just do that. So we're still going to do it the same way. So I'm going to say 7x minus 2 cannot equal 0. Okay, to get rid of that minus 2, I'm going to do a positive 2 and a positive 2. So those 2's are gone. I'm left with 7x cannot equal 0 plus 2 is 2. Now, if I want to get that 7 away from that x, they're being multiplied right now, so I want to do the opposite. So I'm going to divide. Okay, the best part about this, you can leave it as a fraction just like that. You don't have to find the decimal. You can just leave it as a fraction. So I can say x cannot equal, and I'm going to leave it as a fraction, 2 over 7. Okay, so I'm going to put it right up by this other one. So x cannot equal, and I'm going to say 2 over 7. So that's one of my answers. My second answer, I have to decide what I'm going to cancel out. If this is 7x plus 2, and this is 7x plus 2, because it's a top and bottom, I can cancel this and I can cancel this. Okay, so on the top, I'm just going to leave open because right now there's nothing there. But on the bottom, I have the 3 and then the x minus 3. You don't have to distribute that 3. You can just leave that just as it is. There's nothing on the top. So when there isn't anything on the top, we're going to hold that spot with a 1. So this is our undefined values. That's one of our answers. And then this is our simplified rational. Okay, let's look at number 7. Okay, this one has 3 pieces on the bottom, so we're going to do our undefineds first. So I have this one, and then I have this one. Okay, So let's start with our first one. X cannot equal, it's a -3, so now it's going to be a +3. I'm going to say X cannot equal, right now it's a +5, so I'm going to do the opposite, a -5. And then one more, X cannot equal. Right now it's a -7, so it will become a +7 if we don't want it to equal 0. Okay, so this is my undefined values. And now I'm going to look, is there anything the same on the top and the bottom that I can cancel out? Well, this is an x minus 3, and this is an x minus 3. They're top and bottom, so those can be canceled. And then I also have this x minus 7 and this x minus 7. They're top and bottom, so those can be canceled. So I can just come over here and say equals. The only thing that I have left on the bottom that I haven't crossed off is that x plus 5, so that's going to stay on the bottom. And then there's nothing on the top, so I'm just going to put a 1 on the top to hold the space. So this is my simplified. So I have my two answers. I have my undefined and I have my simplified. Okay, let's try number 8. Okay, so this one is the one I was telling you about. We could set that up and set it equal to 0, but I'm going to show you a little bit faster way to do that. I'm going to say x cannot equal. Okay, let's pretend that that 5 isn't next to that x. Let's just pretend it would be x minus 2. Well, if I want the opposite of minus 2, I know it's going to be a positive 2, but that 5 is next to that x, so it's being multiplied, so I want to do the opposite, so now I'm going to divide. So it's a positive 2 divided by a positive 5. And remember, we can just leave that as a fraction, so you don't have to do anything more with that. Okay, this one I'm going to say x equals, and I'm looking at this one right here, so it's a positive 6. No, it's going to be the opposite, so not equals, sorry, not equals. It's going to be the opposite. It's going to be a negative 6. And now I'm going to look and see, is there anything on the top and the bottom I can cancel out? So this is on the top, this is on the bottom, so this and this can be canceled out. So now what's left on the top is that 4, and then what's left on the bottom that I haven't crossed off is the x plus 6. Oh, excuse me, sorry. Okay, so this is my simplified. These are my undefined values. Okay, let's try number 9. Looks like we got one of the easy undefined values, and then we have one of the ones that we have to think a little bit more for. Okay, so I'm going to start with right away, x cannot equal. Right now it's a -3, so it's going to be a positive 3. And then I'm going to look at my blue one. X cannot equal. Okay, let's pretend that that 3 by the x in my blue parentheses, let's pretend that 3 is not there. So it's just x minus 10. The opposite of minus 10 would be a positive 10. But because you have that 3 by that x, they're being multiplied. So I'm going to do the opposite. I'm going to divide by that 3. So that one's done. Okay, now we're going to look and see, is there anything on the top and bottom we can cancel out? So I have x minus 3 on the bottom. Here's my x minus 3 right here. So those two can be canceled. I'm going to go ahead and cancel those. And then I also have this 3x plus 10 and this 3x plus 10. Those are top and bottom, so I can cancel this and cancel this. Okay, so my simplified, I still have the x plus 5. And then there's nothing left on the bottom, which is fine. You can put that 1 on the bottom. You don't have to. If your opening is on the top, you absolutely have to have the 1 there. But if your opening's on the bottom, you can put that 1 on the bottom, or you could just say that x plus 5 and put, that can be in parentheses if you want. It doesn't have to be in parentheses. This one is in parentheses, so I tend to take it exactly like it was, but you wouldn't have to. Okay, so here's my simplified, or here's my simplified. Either one of those would work. And this would be my undefined. Okay, let's do one more. Number 10. Okay, I'm going to look at this one and then at this one. I'm going to find my undefined. So x cannot equal. It's a positive 8, so now it's going to be a negative 8 in my red. When I look at my blue I have to think a little bit more about. X cannot equal. Okay, let's pretend that the 2x isn't there, and let's just pretend it's x plus 1. So the opposite of positive 1 would be a -1, but it's not just x, it's 2x, so it's being multiplied by that 2. So now I have to divide by that 2. Okay, so these would become my undefined values. And then I'm going to look, do I have anything on the top and the bottom that are the same? I sure do. So I can get rid of this and get rid of this. Okay, so I still have the 2x plus 1 on the bottom inside parentheses. You don't necessarily have to have those parentheses. I just like to keep those. Okay, here the top is open. You can't have an open top. You have to have something that holds that top spot. So I'm going to put a 1 right there. All right, that is all you need for number 9, which is simplifying expressions, simplifying rational expressions, and this is without factoring. So like I said, when we did that first page, these two we're actually going to do tomorrow. So you'll learn that tomorrow, but starting with 3 and then 4. So cancel out any of the factors that are the same and then state the undefined values. I probably would have switched 3 and 4 around because like we did in the notes, we stated the undefined values and then we canceled out the factors that were the same. All right, go get after it.